G'day, it's Prezzo here, and welcome back to part 2 of turning a cheap wood cutting bandsaw into a useful metal cutting bandsaw. And in the last episode I left you with the bottom wheel being rotated by the motor, and we had a look at the gearbox assembly and how that was mounted to the back of the saw. And we had the top wheel fitted, but at that stage I hadn't shown you the bandsaw tensioned up on the wheels and actually rotating. Also in the last episode I was using an inappropriate gearbox. I had a 60:1 reduction. What I really wanted was a 30:1, and I've got that now, and I've mounted the wheel permanently onto its shaft. See, there's a big brass washer there and a draw bolt which keeps the wheel mounted on its keyway and mounted to the extension on the gearbox spindle. As you can see, I've got the blade fitted, it's tensioned up. I've got the blade guides fitted now. There's still a lot of work to do on those, but it's sort of at the point where I think it's going to go forward. I'm going to run this down. I'm going to show you what it looks like with the blade tensioned and running on the wheels, and you can judge for yourself whether we're getting anywhere with this project. So here we go. Electrically safe, as you can see. Now the first thing you might notice is it's way quieter than when I showed you in the last video. And that's because I did a lot of work on the coupling between this extension shaft and the gearbox, and also the motor mounting, which we'll look at shortly. Okay, problems. Let's talk about those now. I still have the saw blade running half on and half off that bottom wheel. I need to do something about aligning that bottom shaft there to make sure that doesn't happen. It's tracking more or less correctly at the top, and I can adjust that, or the tracking adjustment is still there. The blade guides are sort of doing their job, but the blade is riding too far forward at this stage. I can't get the ball bearing, which sits in the back of the blade, far enough forward to allow me to have the blade just clear of that. So once again, there's some adjustment needs to be done there. Okay, so the big question I'm sure you're all asking yourself is, does it actually cut metal? Well, let's have a look. Okay, you'll have to forgive this temporary sort of table I've got on here. This bracket still has to be attached to the back of the saw, and the table fits on top of that, and I just haven't got to that stage yet. So I've just got a piece of hardwood clamped down to the top of the frame here, and this would be enough to give you a demonstration. So this is 3mm thick aluminium. We'll just see how that goes. So, I'm not sure what the cutting speed there is, but that's as good as I want this to be. This is pretty much what I want it for. It's just for cutting up this sort of stock quickly and simply without having to break out things like a jigsaw and clamps and straight edges and all that sort of stuff. So that's aluminium. I'm happy with that. Let's try a piece of steel. This is roughly the same thickness in a galvanized steel. Okay, a bit slower, but it's controllable. I can see what I'm doing. I can guide that cut along a line very easily. I can cut into a drilled hole if I want to take out sort of a U-shaped section out of a piece of stock. I can take a strip off an edge. You know, it's pretty much what I expected this to do. Now, just trust me on this, it's early days. I've got a lot of work to do yet with this blade guide system to make sure that that's supporting the blade properly. I don't have the blade tensioned up fully at this stage because of the problem I have at the bottom here. But as a proof of concept, I'm feeling like this is going to be as good as I want it to be. Okay, so let's have a look at how I got to the point where we got these blade guides fitted. I'll show you the manufacturing process for that. And then we're going to look at the motor issue. This is the only bit that was left of the blade guide assembly. The one on the bottom below the table is completely missing. This one just came like that and had a ball bearing mounted on here, and I'm guessing that it was designed to fit underneath this aluminium extrusion. The ball bearing was to take the back truss from the blade, but there was no evidence of any sort of side-to-side support for the blade, so I'm not sure how that was meant to work. So what I've done is I've made up some patterns for some new castings. So this is the one for the top blade guide assembly. There'll be a ball bearing fitted on here, and these core prints are for a square hole that'll go right through the casting later on. We're going to fit some brass square side supports that will be adjustable and can be locked in place with a grub screw from the front. I decided to go that way because, I don't know, it's simple, it's robust. I had a saw with that system on it and it seemed to work quite well. So that one will go there. The bottom one will be screwed in from, how does that work? Yeah, that's going to be screwed in from the rear to the back of the saw frame. So what we need to do is get those castings made, get a machine and fit them. Okay, situation report. This casting here turned out good. Alright, the core has done its job. It's made the square hole through the casting where the brass blade guides will go, and the other gap through here is where the blade will pass through the blade guide on its way down to the bottom of the table. So that's all good. And this bit here, well, rookie mistake really. I put the runner in the drag side of the mould without referring to the cope side or the top side, and this projection or overhang was there. So the runner ended up being in the way. But it doesn't matter because this is all going to be machined away. I've got to put an accurate machine surface on this projection here for the bearing. So the bearing itself is going to go sort of like that. I'll show you on the other one. So here on the other one you can see the bearing is going to sit on that space there, and it'll be mounted on an eccentric so it can be rotated around to take up the gap between the blade and the bearing outer surface. Now this one, well, you judge for yourself. It looks like the core got displaced sideways when I closed the mould. That side there you'd say, well, that's okay, that's acceptable. This side here is a bit more ugly, and disappointed, but I think I can make it work. So I'm going to go ahead and machine this anyway. Okay, this one turned out great, and obviously that's a much easier casting to do, and I'll go ahead and get that machined as well. Now, you know, I knew that this was going to be problematic, and I just wanted to set myself a bit of a challenge really to see if it could be done. In hindsight, I sort of knew that it was prone to failure because you've got to close the mould on that core, and there's every chance it's going to sort of move a little bit or smash away a part of the top of the mould. This is my casting for the lower blade guide on the bandsaw. This square hole was actually cast in using a core, and it came out pretty close to size. You can see I've scribed in the correct position of the edges of that square hole. This is the brass stock that I'm going to be using as my blade guides. So on this one I'm going to machine a pocketing operation just to bring that square hole to an accurate shape. It's probably going to be a little bit undersized, and I'll need to carefully file that to finish up. The other blade guide, this one was also cast, but I didn't bother to cast in the square hole, and I've already partially machined this, marked it out. This one I'm going to have to cut that square pocket right from scratch, take out all that material. Yeah, I'm using a 4-flute end mill, 3mm diameter. So I'll go ahead and get this one cut, and then I can file that to its finished shape. It's going to have rounded corners in here which will need to be cleaned out. There's that square brass stock now fitted to those holes, so I had to do a lot of work with needle files just to get the corners sharp, or actually undercut slightly so that brass stock will fit through there. I'm guessing this stock doesn't need to be square, it could be round and would probably still do the job. So there'll be a pair of drilled and tapped holes here, and they'll hold a grub screw just to lock these brass pieces in place. Okay, so now I need to get the other one done. This will be the one that's going to have the full pocketing operation, not just cleaning up the edges. This is the upper blade guide, and I need to get rid of all the stock inside that marked out square there. So I'm going to drill it, because guess what? Drilling is still the most efficient way of removing metal, or one of the most efficient ways. I'll swap over to a 9.5mm drill and drill out most of that material, and then we'll just run the end mill around the edge of the square. Okay, I know that wasn't terribly efficient. I was running that as a pocketing operation, even though I drilled away most of the material, but that's okay. This is where I'm going to drill through 9.9 and ream to 10mm. That's going to support this eccentric, which is where the bearing will fit, and this gives me some adjustment on the back of the blade. So I'll get this all drilled and reamed, and these things are nearly finished. Okay, well, that's most of the upper bandsaw guide done. I'll need to drill and tap some holes with set screws to hold the brass square stock in place, and I need to drill and tap here to attach this to the guide arm on the top of the bandsaw. Okay, it's time for an update, and I've been doing a lot of work on these blade guides, because until I get those done we really can't test this saw out in a serious way. And what I tend to do with this is I model the parts in my 3D drawing package, which is Autodesk Inventor, but you can use whatever you've got. And these drawings are just a guide. You know, I update these as I work on the prototypes. And remember that this whole machine is a prototype. There are going to be changes that need to be made along the way, and we'll look at those in a minute. This is one of the guides that I've got that's almost finished. So this has been machined on the CNC mill and my manual mill. Remember, these were rough castings when we started, and you can see the brass guide box now in place. And why did I use brass? I don't know, it's cheap, low tech. I've seen some with bearings, you know, rubbing on the edge of the blade, but I don't know, it just seemed like a lot of work for no reason really. The back thrust on the blade is taken care of by this one bearing here, and it's mounted on an eccentric shaft so that we can rotate that, and I can get 3mm of movement between the back of the blade and the face of the bearing. So we're going to look at how I've done that in the lathe in a minute. Now this is the upper blade guide. I can put a screwdriver slot in the end of that 8mm threaded section there, and I can rotate that and then tighten up the M8 hex nut. Now I can't do that on the lower blade guide. It needs to have like a hex extension on there, so I can turn that with a spanner. I just can't get a screwdriver in there. But so far these are looking pretty good. So this is the lower guide here, and I've got the same brass blocks sitting in there at the moment. They're locked down with a pair of grub screws, socket head grub screws, and you can see the face where the bearing will be going and this has been machined. So let's head over to the lathe. We'll have a look at how we're going to do this. Okay, this is the part that I'm making at the moment here now. This is a bearing spindle, if you like to call it that, and I've already machined all of these features on this end, and all I need to do now is cut this journal for the bearing. And on this other one, I haven't dimensioned on this one here, but on this one here you can see there's a 1.5mm offset for the journal that carries the bearing, and so that when you rotate this whole spindle you get a total of 3mm of movement with the bearing to bring it up against the back of the blade. So here's the part. So as you can see there, I've machined everything, including the little hex on the back there. There's an M8 thread, and this is the 10mm surface that fits through the aluminium casting. So what I need to do now is machine that little eccentric on this end. Now this is the setup I'm going to be using for this. So what we can do is put the partly finished job into the collet block. Now if you've got one of these square collet blocks, it makes this whole job really simple. And it's just necessary to lock your part in there. And what I would normally do then is to set that to run true. So I just move my 4-jaw chuck, get it centered, and then we can put the indicator against that surface there. And as we turn that, we can read the total eccentricity. So let me just get this set up correctly. Now I was going to set the dial to 0, and then we're going to sweep this around half a turn, and we'll check the total amount of run out. So that's 1mm, that's 2, and coming up to 3. So I've already done this, but you can imagine that you just have to move the jaws backwards and forwards in one plane until you get your total eccentricity of 3mm. The only thing that gave me grief when I started this process was I forgot that when you move the jaws, you only move half the total amount of error. So if your dial is indicating 3.6, when you move the job you only move at 0.3, and you can very quickly get your job in the position it needs to be. So that's giving me the correct amount of throw. Now for this job, it really doesn't matter whether it's 3mm or 3.1, just as long as we get some movement as we rotate the spindle. But I'll go ahead now, we're going to cut the bearing surface, or at least the spindle for the bearing, and I'll drill and tap for a screw to hold the bearing onto that shaft. So you can see there now we formed the eccentric extension there. I need to get that sized to be an accurate fit for my bearing. But I think you get the idea. I'll get this cleaned up and I'll show you at the end. Alright, so that one's done. Bearing will go on, and we'll put a socket head cap screw in there with a washer just to pull that bearing on there. And that gives me the eccentricity to adjust up the gap between the back of the blade and the bearing. Nearly done. This is the blade guide that came with this GMC saw, and when I first saw it I thought, oh, it's a neat little solution. It's got a sort of a rack and pinion adjustment so you can lower the blade guide. Now the blade guide that came with the machine was that little die casting there, and it had a bearing on it. I'm still not sure how they took care of the side thrust on the blade, but when I had a look, the attachment points were just a pair of very small holes, and there were a couple of self-tapping screws to hold that plate in place. And with my sort of a man's blade guide, didn't seem right to attach that big chunky casting to this extrusion here with a couple of self-tapping screws. So in the end that got the flick, and what I've done is I've made up this bracket. Now Don't judge me on the finish, it's still got a long way to go yet. So this just started out as a piece of hot rolled steel, and I have cut and welded a 90-degree angle on the end of that, and that's been drilled to take a pair of M6 screws, and they're going to be threaded into the blade guide like that. So that was going to slide up and down inside the chassis on these slots, and I'm going to lock that in place with a couple of those little ratchet handles. So there's the assembly for the upper blade guide. Getting close to having that fitted now. This will eventually be sandblasted because I've got a sandblaster now. So get all that cleaned up, and I might even zinc plate this just to make it look pretty. The lower blade guide doesn't need that vertical adjustment, so it's going to be just screwed to a piece of this 10mm thick aluminium plate, and that sort of puts it in the correct relationship to the blade. And this doesn't need to have any of that vertical adjustment, but I'll probably put a slotted hole which I can allow, or will allow me to actually move this left to right to align it accurately with the blade. Doesn't need a lot of movement, just a tiny bit will do, and that will be fixed permanently in place underneath the table. Now the upper blade guide is adjustable. You can see that I can move that up, loosen it off properly. I can move it over that range, and it's held in place by two M6 screws running in a slot. So here is that whole assembly from the back, and you can see here that I've got a pair of these little ratchet handles with a big aluminium washer on the outside, and these are good because you can reposition the handles so they're not clashing with each other, and they give a really positive locking for that blade guide assembly. Where these ratchet handles fit through in the frame of the saw, there were two existing holes there which were part of the original blade guide assembly. So I didn't drill those, I just made use of the ones that were already there. You can see the slots and the way that that ratchet handle slides up and down. Here is one of the T-nuts. So these were just turned and threaded on the lathe, and then I milled away the sides to create that extension. So that just fits through that 6mm wide slot and is able to travel up and down and clamps everything in place quite nicely. So that bit I'm very happy with. There's the business end of the blade guide now pretty much finished. I do need to do a little bit of work with the positioning of this ball bearing. It's not coming far enough forward. I'm not quite sure how I'm going to tackle that yet. It probably means slotting these, probably needs slotting these holes here so that I can move it backwards and forwards and get some more adjustment. Right, here is the lower blade guide assembly, and it's sort of just sitting there at the moment. This is the part that I'm least happy about, and that was the requirement to have some adjustment on that brass scrubbing block. And it meant drilling a large hole in the side of the frame and protruding that from the frame. Not ideal, but there's very little room to work with here. When the wheel is in place, you sort of just get that quadrant there to fit all of that assembly. So I did the best I could with the amount of space that I had. If we take that blade guide assembly out, you can see how that's been mounted. So what we've got is a piece of 10mm thick aluminium plate. The edge has been rounded over here so that matches the welded seam on the inside of the frame. There's a pair of countersunk head screws, socket head screws there, which attach the blade guide casting to that plate. And unfortunately I don't get any adjustment with this. I can't move it up or down or side to side. I can move the bearing front to back, but I sort of run out of adjustment on that, and I still need to do some work on that to get that fitting tight against the back of the blade like I hoped I would. Now, interestingly, I went to my local hardware store the other day and I found two saws very similar in size to this one. One was a Ryobi, the other one was an Ozito, and both are, cheap Chinese bandsaws with roughly the same form factor and same dimensions. They both have similar wheels to what I've got here, and the blade guide assembly on both of them was, well, admittedly it was only for wood, but I thought it was a pretty cheap rendition of a blade guide. Here's a picture of it close up. Both of them retail for around about $120 to $140 Australian. Both had exactly the same motor that I've got on this machine here, and interesting that you could probably buy one of those saws for $140, but they're so cheap, I imagine that there would be plenty of them lying around as scrap. So if you were able to find one, and because it has the identical motor and probably a very similar sort of frame, you could probably do a similar thing to what I'm doing here. Okay, this is our motor. It's a 250 watt induction motor. It's got a capacitor, and I believe this type of motor is called a capacitor start, capacitor run. There's no centrifugal switch on the shaft, so the capacitor is energized the whole time the motor is running. Now, stupid me, I fitted all of this up and switched the saw on, and I was a bit surprised and embarrassed to see that the drive wheel was running in reverse. And I hadn't considered that I've got a single stage gearbox, so that's obviously, became obvious to me that that was going to reverse the shaft direction. So I thought, well, no problem, I'll just reverse the motor electrically. And when I had a look at it, I realised that there are only 2 wires and an earth coming out of the casing of the motor. I had a look at Matthias Wandel's website, and he's got an excellent tutorial there on induction motors and how to reverse them. According to what I read, this is a very cheap form of motor, and what they do is they couple the start and run windings together inside the coils of the motor so that you can't get at them to reverse them. I didn't mess around with the capacitor, I just left all of that. As you can see, it's still got the original connections on it. And what I did in the end was I just simply took the armature out and I flipped it. Now, you can do this because both of these end shells are exactly the same. They have the same size bearings, they're the same length, same diameter, and there's clearance at both ends, plenty of clearance. So I dismantled the motor, took these shells off, and I turned the armature around, and then I bolted it back onto the gearbox. Now, the only problem was that the 4 holes that you use to bolt the motor onto the gearbox aren't present in the other end of the motor. So I had to drill 4 new holes, and there's enough room inside the casing to put 4 M6 bolts, or 4 M6 nuts, I should say. The only other problem now is that the holes that attach the fan cover to the motor are at this end, so I'll have to drill 4 new holes down this end here. Just thought I'd show you what I meant when I said that you can dismantle this motor and reverse the shaft. So the whole thing is held together with just 4 of these long screws. Now, I've had this motor apart a number of times, so I've only got 2 of the screws in here at the moment. So all I do to get this apart is just tap the shaft just gently. Okay, so there's the forward end, and you can see inside here I put 2 M6 bolts and nuts to hold that casting onto the front of the motor. The armature just comes out like that, and it's got 2 wave washers at the front end to take up the thrust on the bearing. Now, I did have to machine this end of the shaft to make it fit the gearbox. Turns out it was about 14.5 millimeters, 14.7 or something like that. I just kept machining that down and trying it in the gearbox till I got a good fit. I did have to machine that keyway, but the whole, assembly is pretty straightforward. It's pretty basic. Now, like I said, you can, if you're brave, you can cut these connections and take this end shell off, and you can flip it around. That way, the 4 holes that connect to the gearbox are already there. Now, it's up to you how you do that. I did this on the CNC mill. So I was able to take a position off the bearing housing and then set out my 4 drill positions to do it that way. You would have to be fairly accurate if you were doing that. Now I'm not really happy about having these nuts on the inside of this motor. You know, if they ever came loose, you know, they're going to rattle around inside the motor and do some bad things. So I'm going to fit a thing called a rib nut in there, and that's going to allow me to tighten up these socket head screws from the outside without needing to get to the inside of the motor. Okay, this is a rib nut, or sometimes called a nut cert, and this one is steel. It's M6. The outside diameter of that is 8.9 millimeters, and what I've done is I've drilled out the end plate of the motor at 8.9. I've already put 3 of these rib nuts in place here. Okay, on the inside I've already formed one, and you see here that there's a ridge of metal that's been expanded and pulled up tight on the inside of that motor casing, much like a pop rivet. These other 2 have not yet been formed. Alright, and I'll show you how that works. So with the rib nuts in there now, the way that you form these is basically to pull up on the end of the rib nut using some sort of a tool, which can be hydraulic, can be screw operated, lever operated. There's all sorts of different techniques out there. This is a tool that I made myself, and I'll put a card up if you want to go back and look and see how that works. It's very, very simple. It's just a 12mm high tensile bolt. It's been turned down at this end and threaded M6, and I've got a series of these for all different size rib nuts, so starting at 3mm going up to 6, but you can get bigger ones. And inside the tool there's a thrust washer, and if you're careful with the dimensions, you can get this so that it will pull these rib nuts up quite effectively. And let's have a look at doing this one here. Yeah, that one's not done. So all you need to do is to thread that M6 extension into the rib nut. Right, now you get to a point where you feel some resistance. Which is there. Now this stage, you can see it's all a bit floppy and it wants to move around. Just keep pressing down and keep tightening that until it starts to deform the inside of the rib nut. So if I turn that over, I'm not sure if you can see, but there's a bulge starting to form against that inside surface there. So we'll go a bit further. Basically keep going until it feels like it's stopped and it's not going any further. Now you can see that bulge quite clearly. And if I go any further now, I'm going to strip that, so I'll just stop and back it off. Alright, so that's 3 of them done. Got 1 to go. There's the casting bolted back on again. There's the rib nuts on the inside doing their job. But it does mean now that I can disassemble this without pulling the motor to pieces. So that's the only thing you need to worry about if you are going to use this original motor, and in my view you should. It's the right size, it's compact, doesn't consume too much power. It has enough horsepower to cut metal. That's not a problem because of our gear reduction. So in my view, I'm happy with this motor as it is. I like the way it all fits. It keeps the center of gravity low. If you're moving the saw around and carrying it from one place to another, which I have to do, that's good. It makes it easy to transport. So that's where we're at this stage. I'm going to wind this video up here now. In the next video, we're going to look at the finishing, that is making everything look pretty, putting it together. There are a few little extra tweaks that I want to do on this, and I feel confident now that I've got a saw that will do what I want. You know, maybe you're looking at it saying, well, you know, I want to cut steel that's 1 inch thick. Well, this is not for you. This isn't going to do it. So unfortunately, maybe you need something bigger and beefier to do that sort of work. But for me, this is good. Check in next time. We're going to see this maybe finish. Maybe we've got 2 more episodes to go. I'm not sure. But I'm hoping that you're seeing that this has got some potential. Okay, that's all for now. Check me out in the next video. See ya.